Hello everybody. This is your video homework for the evening of 10:11 and 10:12. So you will do these notes on the evening of 10:11 or 10:12, 10:11 for A days, 10:12 for B days. We have a pair of parallel lines with a transversal. I have two pair of alternate interior angles. These are angles that occur inside parallel lines and on the transversal. We're going to be using alternate interior angles in our proofs now, so I want to remind you how they work. If we look at example 2, here I have a drawing of two triangles. I have marked the top and bottom line parallel. Because I have marked the top and bottom line parallel, I have created alternate interior angles. But let's be very careful about where those angles go. The angle must touch not only the transversal, but also the parallel line. You will want to say that this angle is congruent to this angle, but you will be wrong. I have no statement that my sides are parallel, so I cannot assume those are congruent. It's only where the parallel line meets the transversal that I have alternate interior angles. You've already noticed that our proofs in class have gotten to be a little more interesting. I want to talk you through again the process of setting up and solving a proof. We know where we're going. We're trying to prove that triangle A is congruent to triangle E. The first thing we're going to do is write down and mark our givens. BC congruent to DC. BC, DC, given. So it's 3 steps. The statement, the marking, the reason. Check, I remembered that one. AB parallel ED. AB parallel ED. Given again. Check. You'll notice that I colored over my arrows. Even if the arrows are already there, I'm going to color over them to tell myself I see them. Now, whenever I see parallel, I'm looking for some of those parallel line vocabulary. In this case, here's my parallel line, and here's a transversal. You notice I said A, because I actually do have two transversals. I'm going to say that angle B is congruent to angle D. Parallel line, transversal. Parallel line, transversal. Angle B congruent to angle D, alternate interior angles. These almost always go together. There's one more angle that's always congruent in any sort of bow tie situation. That's correct. The angle's in the center. I can't just call it angle C though, because there's two different angles. I'm going to call it BCA. So if I started with B, what letter do I have to start with for the right-hand triangle? D. DCE. And the reason is vertical angles. I'm done now. I can say, therefore, I have blank, blank, blank. I have a, and a, and a. So it's angle, side, angle. My proof statement always goes at the end. If I went too fast for you, pause the video, take the notes, go back and listen to it again before you move on. There's one more example. Okay. This one has nothing marked, so we have to do all of the marking. I've listed your givens in a specific order to make you think about what the given means and what the follow-up statement should be. Let's begin with MP parallel to RQ. Here's MP and RQ. It's given. There will be some sort of follow-up statement. These lines are parallel, and here's my transversal. So I have some congruent angles. Here's the parallel, here's the transversal. Parallel, transversal. Angle P is going to be congruent to angle RQS. You can't just call it Q. There's too much going on there. You have to be more specific. Angle P congruent to angle RQS. Yes, you are allowed to do that. It is not given. It's definition of parallel / corresponding. Because you have parallel lines, it has created corresponding angles. Check it, it's done. Q is the midpoint of PS. Q is the midpoint of PS. Given. Check it. Now my next statement, I made those marks, now I have to make a statement about it. PQ congruent to QS. Definition, midpoint. Miss Meyer, some of you may say, how come you did PQ QS instead of PQSQ? My triangles are facing the same direction, so that congruency would continue to go in the same direction. I have my third given. MP congruent to RQ. It's given. Look at that. There's a given all the way at the end. There's nothing wrong with that. So I can prove triangle M congruent to triangle R because of, it would have helped if I put my markings in here. What? Side, angle, side. Good job.